There's a red dot floating in deep space that, according to the laws of physics as we understand them, should not exist. It looks like a star, roughly the size of our entire solar system. But it's pumping out 100 billion times more energy than any star is physically capable of producing. That's not an exaggeration for the thumbnail. 100 billion. So what is this thing? The strangest part is, the astronomers who found it weren't even looking for it. They stumbled into it by accident, while hunting for something completely different. And by the end of this video, you're going to understand why that accident might quietly rewrite how we think black holes, and maybe entire galaxies, get their start. Let's get into it. A team led by astrophysicist Rohan Naidu, working out of MIT, was running a survey with a pretty poetic name, Mirage or Miracle. The goal was simple on paper. Point the James Webb Space Telescope as deep into space as possible, back to just a few 100 million years after the Big Bang, and try to catch the earliest galaxies that ever existed. Here's the catch though. Some of these ancient-looking galaxies were showing up way too bright. Suspiciously bright, like something wasn't adding up. So with every source they found, the team had to ask a genuinely hard question: is this a real miracle, an actual bright galaxy sitting at the dawn of time? Or is it a mirage, a trick of the light caused by something we haven't figured out yet? While combing through JWST's images, one object stopped the team cold. A tiny, unassuming, impossibly red, and impossibly bright. Now, quick science detour: when astronomers spot something unusually red, the default suspect is almost always dust. Here's an easy way to picture it. When wildfire smoke drifts over a city, the sky can turn deep red, even though the sky itself hasn't actually changed. The smoke is just filtering the light and shifting it toward red. Cosmic dust does the exact same thing to starlight. So naturally, dust was everyone's first guess here too. Except the light from this dot refused to behave the way dust-reddened light is supposed to behave. There was another clue buried in the data, and it was strange. The object was blazing bright almost everywhere, except at certain wavelengths, where the light just disappeared. Completely gone, like someone flipped a switch. That drop-off has a name: astronomers call it a Balmer break. Normally, you see this pattern in the atmospheres of young stars, ones that are maybe a few 100 million years old. Vega, one of the brightest stars in our night sky, shows this exact signature. Here's the twist. This particular break was deeper than any Balmer break scientists have ever recorded. Deep enough that it basically ruled out an ordinary star as the source. And there was one more oddity sitting right next to it: almost no trace of any element beyond hydrogen and helium. No metals, nothing heavier. Just the two simplest elements in the entire periodic table, packed together at an impossible density. So pause here for a second and ask yourself, if it's not dust, and it's not a normal star, what does that leave? Quick pause, and Johan Pucho Key, do you already have a guess? Hold that thought, because it's about to get weirder before it gets clearer. Let's zoom out for a second, because you need this picture in your head for the rest of the video to make sense. A normal star is basically a dense ball of gas, glowing because nuclear fusion is happening at its core, hydrogen slamming together to make helium, releasing energy the whole way. A normal black hole doesn't glow on its own at all, it's dark, invisible, but when it's actively feeding, matter spirals into it through something called an accretion disk, a flat, pancake-shaped ring of superheated gas swirling around the edge before falling in. This new object doesn't fit either box. It's not a ball of gas glowing from fusion, and it's not a flat disk of infalling matter either. It's something in between, a black hole doing the feeding, wrapped inside a thick, roughly spherical shell of gas that behaves almost like a star's outer atmosphere. The black hole takes the place fusion normally holds, as the power source, and that dense gas envelope acts kind of like a pseudo-photosphere, the glowing surface layer you'd normally associate with a star. The researchers built simulations to test one specific idea: could a thick wall of pure hydrogen, with zero dust involved, reproduce that exact reddening pattern? And to their own surprise, it actually worked, but only under one very specific condition. The hydrogen had to be packed at a density closer to the surface of a massive star than to the thin, wispy gas clouds you find drifting through interstellar space. That solved one mystery. It explained the color, the vanishing light, the strange chemistry. But it opened up a much bigger one. Because even with all of that figured out, a hydrogen cloud alone still can't explain why this object is 100 billion times brighter than physics allows a star to burn. Ordinary stars run on nuclear fusion, and fusion comes with a hard ceiling, a maximum brightness baked into the physics itself. Whatever this thing is, it blew straight through that ceiling like it wasn't even there. There's really only one known source in the universe capable of producing energy at that scale, and that's a black hole. So the team went back into their simulations and dropped an actively feeding black hole right at the center of that dense hydrogen envelope, then kept adjusting its mass, running the model again and again, checking the brightness their simulation produced against what JWST had actually captured from the red dot. Eventually, they got a match. The best-fitting scenario points to a black hole roughly 100,000 times the mass of our Sun, wrapped inside a thick, glowing shell of hydrogen gas about the size of our entire solar system. Picture that for a second, a black hole draped in a star-sized curtain of gas, and that curtain is the only reason we're able to see it glowing at all. Not fusion. Not a normal accretion disk spinning like a pancake around the black hole, the way you'd usually picture one feeding. Something in between a star and a black hole, something we didn't even have a name for until now. The team gave it one MOMBH*-1. Black hole star, number 1, because they're fairly confident this won't be the only one we ever find. And here's where the story stops being about one weird red dot, and starts being about something much bigger. For years, JWST has been photographing tiny, unexplained red points scattered across nearly every deep field image it takes. Nobody could quite agree on what they were. Genuinely one of the most debated puzzles of the entire JWST era. If black hole stars are real, and common, they might be the answer that's been sitting in plain sight this entire time. Naidu and his team pointed out that essentially every one of these little red dots is consistent with hiding a black hole star inside a young, forming galaxy. What makes MOMBH*-1 different isn't that it's the only one, it's that it's so blindingly bright, it's completely outshining its own host galaxy. We're not looking at a galaxy that happens to contain a black hole star. We're looking at pure, unfiltered black hole star light, with basically nothing else getting in the way. And this isn't a fringe idea getting quietly whispered about at a conference somewhere. The full analysis went through peer review and landed in Nature, alongside Naidu's MIT colleague Robert Simcoe and a wider group of collaborators from other institutions. That matters, because extraordinary claims like this one get picked apart hard before anyone lets them through, and this one held up. Now here's the part that actually matters beyond just being a cool discovery. If this really is a new evolutionary stage, a phase where a young, newborn black hole wraps itself in dense gas and blazes away before eventually settling down into something more familiar, then this might be a step that almost every massive black hole in the universe once passed through. Including, quite possibly, the supermassive black hole sitting silently at the center of our own Milky Way, right now, as you're watching this. Sit with that chain reaction for a second. These objects may control when, and where, stars are able to form nearby. They might decide when star formation switches on in a region, and when it shuts off completely. And star formation is the starting line for everything that comes after it, planets forming around those stars, and somewhere much further down that long, long chain, life eventually showing up to look back up at the sky and wonder how any of it got here in the first place. So that red that we opened this video with? It might be a fossil, a leftover snapshot of the exact process that made supermassive black holes possible everywhere, including the one quietly anchoring our own galaxy at this very moment. Wild, right? One accidental discovery, made while a team was hunting for something else entirely, and it might be rewriting the origin story of every massive black hole in the cosmos, ours included. And remember that word from the very start of this video, mirage? That's basically the punchline of this whole story. The team went looking for real, early galaxies, and instead they caught something pretending to be one, a mirage that turned out to be far more interesting than the miracle they were originally chasing. Sometimes the accident is the discovery. There's still a lot we don't know. Is MOMBH*-1 a rare freak event, a 1 in a billion snapshot caught at exactly the right moment? Or is this phase so short-lived, cosmically speaking, that we're only now catching one because JWST is finally powerful enough to spot them at all? Naidu's own team suspects it's the second option, that this stage might be brief, but almost universal, meaning practically every massive black hole passed through something like it on the way to becoming what it is today. Here's a question for you, and I actually want an answer in the comments. If black hole stars like this one really were a normal, common phase every big black hole goes through, does that change how you think about our own galaxy's black hole? Or does it just make the universe feel a little stranger than it already did? Think about it this way too. Somewhere, roughly 13 billion years ago, an object almost exactly like MOMBH*-1 might have sat at the center of what would eventually become the Milky Way, quietly deciding which patches of gas were allowed to collapse into stars, and which ones weren't. Every planet that ever formed here, every version of Earth that could have existed, might trace back to a phase like this one. That's not a small claim, and it's exactly why a single red dot has astronomers this excited. If your brain just did a small loop trying to process all of that, good, that means it landed exactly the way it should. This channel exists for exactly this kind of moment, discoveries that sound like science fiction until you realize they came out of a peer-reviewed paper. So if you want more of that, stick around, subscribe if this kept you hooked for the last few minutes, and let's keep chasing the weird stuff the universe keeps hiding from us. And honestly, this probably won't be the last black hole star we ever talk about here. JWST is still scanning the sky, still finding more little red dots every few months, and somewhere in that pile of data, there's likely a whole population of these things waiting to be confirmed. When the next one shows up, you already know where we're going to be, breaking it down, piece by piece, the same way we just did with this one. See you in the next one.